Okay, welcome everybody. Today we're going to talk about some Chapter 3 quadratic applications, which of course means word problems. We actually saw some problems similar to this earlier in the chapter, but now that we've learned so many ways to solve quadratics, we're able to kind of look at and solve more interesting and more complex problems. So the majority of our problems are going to involve something called the vertical motion model. The vertical motion model can be used to solve any problem where an object is thrown, launched, or dropped, and that vertical motion model is shown right here. So h of t equals negative 16t squared plus v sub 0 t plus h sub 0. And again, that's how you say it, v sub 0 and h sub 0. Those are little subscripts. So let's go ahead and talk about what each different part of the formula means, and then we'll go ahead and see some problems where we put them in action. So h of t, that represents the height of the object at any given point in time. Please note that negative 16 out front, that is a constant that takes into account gravity and will never change so long as the problem is in feet per second. Just so you know, if it was meters per second, it would be negative 4.9. And if there is a meters problem, we would likely give you the equation as opposed to asking you to make one. And if there are any other problems under which negative 16 doesn't work, we will give you those equations as well, but assume that it's negative 16t squared unless you hear otherwise. T is always the time the object is in motion, and it's always going to be in seconds. If you think about any time you've ever seen anything thrown or launched or dropped in the air, it is never in the air for very long, a couple of seconds at most. So just make sure you know you're always going to be using seconds. So v sub 0, that is called the initial velocity, and you would give that unit in feet per second. Or again, that could change if it was a different measurement, but we'll probably be in feet. And it's the initial velocity of the object when it was thrown or launched. And there's three different scenarios. So the first scenario is you can have a positive initial velocity if the object that you're throwing or launching is going up into the air. You're going to have a negative initial velocity if that object is being thrown or launched downward. Then you're going to have no initial velocity if an object is dropped. So lots of different things you're going to be asked to find here. So h sub 0 is the starting height, which again, all the units have to agree. And for the most part, we're going to be in feet. And it's the starting height from which the object was dropped or launched. So very important information here in this box. Obviously, if you printed it out, you have it handy. If you didn't print it out, you might want to go back at some point and just make sure you have it as a reference. Lots of different things you're going to be asked to solve with these problems, but a common question would be to ask you to find the maximum height. So as a reminder, the maximum height of a quadratic is always a vertex. The formula for vertex is negative b over 2a, and notice I'm using t instead of x because your variables in this case are always going to be time and height. There's another way to find the maximum on the graphing calculator, which we'll talk about in the next lesson, but everything today can be solved without one. And just as a reminder again, everything that you do in terms of the vertex is always going to be the time and then the height, where t is the time it takes to reach the maximum, and then h is the maximum height itself. So all the different variables in the equation, and now we're going to go ahead and try to solve some problems with them. So take a look here at the first three. In the first three problems, all I'm asking you to do is insert the information into the appropriate slot in the vertical motion model. Eventually, you're going to have to create an equation and then solve it. For now, we're just making sure we understand how to set it up. So going to definitely start with h of t. And then an object is thrown down with a velocity of 20 feet per second. So I know it's going to be h of t equals negative 16t squared because of the fact that the object is thrown down with a velocity of 20 feet per second. So that's the initial velocity, which because it's being thrown down, that's how I know that I'm going to make it negative 20. Then it's being thrown from a starting height of 15. So if the starting height is 15, then I'm going to go ahead and do a plus 15 in the back. So again, it's always h of t equals negative 16t squared. The initial velocity goes in the middle, negative because you're throwing it down, and then the start height goes in the back, 15 because that's where the problem is starting. In number 2, h of t equals negative 16t squared. The fact that they're telling you that the object is dropped, well, if you drop something, you're not putting any velocity behind it. You're simply letting it fall out of your hand, which is why the initial velocity would be 0, which is why there would be no middle term. The fact that you are dropping it from a starting height of 26, that's how you know that you're going to have a plus 26 in the back. Finally, for the third one, h of t equals, so because the object is being launched up with a velocity of 6 feet per second, we know that we're starting with negative 16t squared. Initial velocity is 6. Because it's going up, that's going to be a positive 6t. And then the fact that they're telling you that you're launching it from the ground. So if you're launching it from the ground, that means that you are launching it from a height of 0, which means you could put a 0 in the back, or usually we just leave it out. So again, you have to understand what the different words mean in terms of how they translate into the equation, because if you don't have the correct equation, obviously you have no chance of being able to solve the problem. How can we kind of put all that together? Well, take a look at number 4. The path of a model rocket is given by the following formula. H of t equals negative 16t squared plus 96t. How many seconds will it take for the rocket to reach a height of 80 feet? So in some problems, you're going to be given the equations. In some cases, you have to make it. In this case, it's given to you. So you just have to understand what it's telling you. So the fact that it's a 96t, that's how you know that the initial velocity is 96 and it's being launched up. The fact that there is nothing in the back is how you know that the starting height is 0, which is how you know that this rocket is being launched from the ground. So think about the picture. Here's the ground. The launch is upward and then eventually comes back down to Earth. So you have a full parabola here. That's what you should kind of be envisioning. They want you to answer how many seconds will it take for the rocket to reach a height of 80 feet. So if you're trying to find a height of 80 feet, you're going to plug that in for h of t. So 80 equals negative 16t squared plus 96t. Your ability to solve this equation, well, that is what we have been doing for the entirety of the chapter. So I'm going to put everything on one side equal to 0. And because I like my squareds to be positive, I'm going to go left side. So add the 16t squared minus 96t plus 80 is equal to 0. The first thing you should do when you try to solve this is you should try to look for any common factors. If there were any common factors common to each of these terms, you could divide it away. Divide away the biggest possible value that you can, and sometimes even a negative one. So luckily for us in this case, 16, negative 96, and 80, you can actually divide a 16 away from all of those, which gives you a nice positive 1t squared minus 6t plus 5 equals 0. You now have 3 different solution methods you could use for this. You could use the quadratic formula, completing the square, or factoring. To me, I see pretty easily 2 factors of positive 5 that add up to be negative 6. That would be t minus 5 and t minus 1. Not all the problems are going to factor, but if it does, you certainly can. Otherwise, use completing the square or the quadratic formula, both of which would be pretty good options in this case. So of course, when you actually solve, you're going to get the opposite. So t equals 5 and t equals 1. Now that we're in a world of word problems, you have to use them in terms of the units. So that would be seconds. And then you also have to decide whether or not both of your answers actually make sense. When would they not make sense? Well, it would not make sense if they were negative. Obviously, you can't have any negative values of time. The fact that they're both positive in this case actually does make sense. And I want you to think about what that means in terms of the rocket itself. So again, over here, this is the path of the rocket. Started on the ground, goes all the way up to its maximum height, and then eventually comes down. The fact that I got 2 positive answers actually makes sense here because I'm going to pass 80 feet once on the way up and once on the way down. So both of those answers make sense. So I'm going to declare that at both 1 second and 5 seconds, that's when the height of the rocket is exactly 80 feet. Take a look here at number 5. Notice in number 5, there is no equation, so you're going to have to make one for yourself. A diver jumps off a 20-foot high diving board with an initial upward velocity of 4 feet per second. Use the vertical motion model to determine after how many seconds the diver hits the water. So here is all the important information that I need to get me started. So I know that this is going to be h of t equals negative 16t squared. So an initial upward velocity of 4 feet per second, that's going to be plus 4t from a 20-foot high diving board gives me the following equation. Think about what's happening here. So not starting at the ground, in fact, starting at 20 feet. If you've ever seen anyone jump off a diving board, they don't just launch their body into the water. They jump up, maybe do a little move, and then eventually head towards the water. So you don't have a full parabola here, you only have part of one. That's going to kind of be the visual that we need in terms of the answers. If they're then asking you when you hit the water, hitting the water means you're going as low as you possibly can, which means that the height of the diver would be 0. So you're going to set this equation equal to 0. And then you're going to think about solving. So in the previous problem, we were able to divide everything by 16. Unfortunately, I can't divide by 16, but 16, 4, and 20 all have a 4 in common. And because of the fact that I want there to be a positive out front, I'm actually going to divide everything by -4. So if I divide everything by -4, I'm going to get a 4t squared minus t minus 5. So from here, I could try to factor it. Maybe it would work, maybe it wouldn't. Definitely completing the square would not be a good move here. So I'm going to do the quadratic formula. So instead of x equals, I'm going to say t equals, because this is time. Doesn't matter if you say x by mistake, but just kind of keep it in mind. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So t equals 1 plus or minus. Under the radical, that's of course the discriminant. So 1, and then so 4 times 4 is 16 times 5. That's going to become a positive. So that's going to be 1 plus 80, which gives me the square root of 81 all over 2 times 4 is 8. I'm going to move over to the side here for a little bit of extra room. So that's going to give me t equals 1 plus or minus. The square root of 81 is 9. So divided by 8. And then I'm going to actually turn that into my 2 answers. So t equals 1 plus 9 over 8. That's going to be 10 over 8. And here's the thing. We haven't really been doing a lot of decimals. We've been simplifying the radicals. But in this case, it does make sense to do a decimal. It wouldn't make sense to say that someone is in the air for 1 plus 9 divided by 8 seconds. You would actually convert that to a decimal. And then your second answer, 1 minus 9 over 8, that would give you negative 8 over 8, which would give you negative 1. So take a look at those 2 answers, one positive, one negative. Because of the fact that you do not have the full parabola, you only have part of the parabola, means that the negative answer that you got represents the part of the quadratic that doesn't actually exist. So you're going to reject that answer, which means your only answer here is 1.25. And again, you really should put the unit, so that would be 1.25 seconds. So you are allowed to use decimals for these types of problems. Again, it really only makes sense if you do, and you can either round them to 1 or 2 decimal places as appropriate. Take a look here at number 6. An object is launched upward at an initial velocity of 64 feet per second from a platform that is 80 feet high. So I'm going to go ahead and need an equation. So h of t equals negative 16t squared, launched up, so positive 64t from a platform of 80 feet would be plus 80. Think about what this looks like. So you're starting at 80, you're launching something up, and then it eventually returns to the ground. So again, it's not a full parabola, it's only part of a parabola. Both of these questions are asking you about the maximum height. So when and what means you need both the time and the height. And of course, remember that the maximum would be the vertex, and that is up at the top. In order to find that vertex, you're going to remember that the vertex is going to be time, comma, height. And to find the first value of the vertex, it's normally x equals negative b over 2a, but in this case, it's going to be t equals negative b over 2a. So that's going to give me negative 64 over 2 times negative 16. Remember to do the denominator first. So negative 64 divided by negative 32. That gives me a positive 2, and that would be positive 2 seconds. Then what is the maximum height? So to find the maximum height, you're going to plug that 2 into the equation. So you're going to find h of 2 would be equal to negative 16 times 2 squared plus 64 times 2 plus 80. Using a calculator very carefully, if you plug that in, you're going to get a maximum height of 144 feet. Then just kind of stop for a second and make sure that it makes sense. The fact that you got a positive time of 2 seconds, that should work because of the fact that you were starting off at 80 and then you launched it up. It makes sense that it will go up to 144 feet and then eventually come back down. Take a look at number 7. At Fenway Park in Boston, seats are offered on the top left wall. A person is sitting there and he accidentally drops his sunglasses. The height of the sunglasses over time is given by the following: negative 16t squared plus 68h, plus 38, excuse me. Notice that in this case, the h is just an h as opposed to being h of t. There is no difference. From time to time, you'll see just an h as opposed to an h of t, but they really are equivalent and mean the same thing. So how long will it take for the sunglasses to reach the field and round to the nearest tenth? So first, just to make sure you understand about the equation, and again, if you want to rewrite it as h of t, feel free. Negative 16t squared is always the case. The fact that this guy dropped his sunglasses, you would hope that anybody at a baseball game is not throwing their sunglasses onto the field. So because he simply dropped it, that's why there is no velocity. And then the fact that it's plus 38, well, that must mean that he is 38 feet above the field level. How long will it take to reach the field? Well, again, we're going to assume that the field means a height of 0. So this is an interesting quadratic because notice there is no middle term. If there is no middle term, hopefully you remember the very best way to solve is just by using square roots. That means you're going to put the terms on opposite sides. Remember now that because it's a word problem, decimals are allowed. So when you divide both sides by 16, you're going to get t squared equals 2.375. You're going to take the square root. Don't forget your plus or minus. And then the square root of 2.375. Again, you're not going to be able to simplify that, so you're going to go ahead and just find me the decimal. So the square root of 2.375 is approximately plus or minus 1.5. Again, you really only want the positive answer because the negative answer does not make sense, and so you would use a unit of seconds, which means it takes only 1.5 seconds for the sunglasses to reach the ground. Again, try to envision that. Somebody up in the stands drops their sunglasses, they pretty much immediately fall to the ground. They don't kind of hang around, suspended in air. That just doesn't really make sense. Don't forget the plus or minus because that is important, but of course you have to understand why you're rejecting the negative answer. Time can never be negative. That doesn't make sense. Our final problem here. So a gannet is a bird that feeds on fish by diving into the water. This bird spots a fish on the surface of the water and dives 100 feet to catch it. The bird plunges towards the water with an initial velocity of negative 88 feet per second. How much time does the fish have to swim away before the bird catches it? And round your answer to the nearest tenth. So kind of a fun and interesting problem here, if you can imagine. Will the bird catch the fish or not? So let's go ahead and start off with h of t equals negative 16t squared. Because the bird is plunging towards the water, that means its initial velocity is negative 88 downward times t. Because he dives 100 feet, you can assume he is 100 feet up in the air. If you're trying to figure out how much time does the bird have to swim away before it's caught, you can assume that that is when the height is 0. If the bird is starting at 100 feet and launching itself towards where the fish is, you can assume that that would be 0 feet is when he actually catches it. So again, from here, if at all possible to reduce the numbers, you should. So I'm going to divide what's common to each, which is actually 4, and even better than 4 is negative 4, because I just like to have a positive out front. So that's going to give me a 4t squared plus 22t minus 25. Again, it's time for you to decide what method makes the most sense here. It might factor, it might not. Definitely don't complete the square. So obviously, when in doubt, go ahead and do the quadratic formula. So ABC. So again, instead of x equals, it's t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Underneath the radical, of course, the discriminant, you're going to calculate that. So 22 squared minus 4 times negative 25 is going to give you 884, and then all over 8. Something to remember here, not only will negative time values not make sense, but if you were to ever get a negative under the radical, that would be bad. You can't have imaginary time units either. So if you do get a negative under the radical, it either means that whatever you're solving is not possible, or more likely you're just making a mistake. So again, in the past, you would have actually simplified that, but because we're allowed to do decimals, you're now going to go ahead and do the two calculations. So negative 22 plus the square root of 884 divided by 8, compared to negative 22 minus the square root of 884 divided by 8. You're going to always make sure you do the numerator in your calculator and then hit enter and then divide by 8. You have to do that first, or else you're not going to get the right answer. So you should test it in your calculator, do negative 22 plus the square root of 884, hit enter, then divided by 8, and you should get 0.97. Whereas if you do negative 22 minus the square root of 84, the square root of 884, then hit enter and divide by 8, you're going to get a value of negative 6.5. Reject the negative answer, take the positive answer, and of course, that is going to be time in seconds. So for tonight's homework, it's just a couple of problems, some of which you just have to set up the equation, some of which the equation is already made for you, and then some of which you have to set up the equation and then solve. For each problem, determine whether you should set your equation to something, either 0 or a certain value, 10 feet, 5 feet, or whether you're solving for the maximum. And remember, it's okay to have decimal answers. So if that happens, don't be alarmed. So thanks for tuning in, guys, and we will catch you next time.